In this video, I'm going to do some more examples of simplifying radical expressions, but these are going to involve adding and subtracting different radical expressions. And I think it's a good tool to have in your toolkit in case you've never seen it before. So let's do a few of these. So let's say I have 3 times the square root of 8. We learned before that's actually the principal square root of 8, or the positive square root of 8, minus 6 times the principal square root of 32. So let's see what we can do to simplify this. So first of all, 8, we can write that as 2 times 4, which is this, when 4 is a perfect square. You might already recognize that. We could further factor that into 2 times 2, but I don't think we need to. So we can rewrite 3 square roots of 8 as 3 times the square root of 4 times the square root of 2. Right? This is the same thing as the square root of 4 times 2, which is the square root of 8. So this term is the same thing as that term. And then let's look at 32. We want to do the square root of 32. 32 is 2 times 16. Once again, 16 is a perfect square, so we could stop there. We could, if you didn't realize that, you would factor that as 4 times 4. You'd see that twice. You could even go even further down to 2 times 2 and all of that. But you see immediately that's a perfect square, so we can stop there. So this second expression can be written as minus 6 times the square root of 16 times the square root of 2. Right? This is the same thing. This right here, I want to be clear, is the same thing as the square root of 16 times 2. You can separate out the square root of 16 times 2 is the square root of 16 times the square root of 2. We saw that with our exponent properties. Now, what does this first term simplify to? This is 3, clearly. This right here is a 2. So you have 3 times 2 times the square root of 2. That is 6 times the principal root of 2. And then from that, we're going to subtract, well, what's this term right here? That is positive 4. So 6 times 4 is 24 times the square root of 2. And we're not done yet. If I have 6 of something, and I'm going to subtract from that 24 of that same something, what do I have? I have 6 square roots of 2, and I'm going to subtract from that 24 square roots of 2. Well, this is going to be equal to 6 minus 24 is negative 18 square roots of 2. And hopefully this doesn't confuse you. Remember, if we had 6x minus 24x, we would have minus 18x, or negative 18x. Now, instead of an x, we just have a square root of 2. 6 of something minus 24 of something will get us negative 18 of that something. Let's do another one. Let's say I have the square root of 180 plus 6 times the square root of 405. So this is really an exercise in being able to simplify these radicals, which we've done before, but you can never get too much practice doing that. So let's just do the factorization of these right here. So 180 is 2 times 90, which is 2 times 45, which is 5 times 9. And we could factor 9 down more into 3 times 3 to realize it's a perfect square, but we could leave it like that. So this first term right here, we can write as the square root of 2 times 2 times the square root of 5 times the square root of 9 times the square. I'm going to put the square root of 9 out front. So the square root of 2 times 2 times the square root of 5 times the square root of 9. Now, what does this second term equal to? So let's factor it out. 405, that is 5 times, I think it's 81, but just to verify, 405, 5 doesn't go into 4, so let's go into 40. 5 goes into 40 8 times. 8 times 5 is 40. Subtract, you get a 0, bring down the 5. 5 goes into 5 one time. Right, 81 times. 81 is 9 times 9. You could factor more if we were trying to do the fourth root or something like that. But we want to just do a square root, and we have a 9 and a 9, so no need to factor anymore. So this second expression right here is plus 6 times the square root of 9 times 9, 9 times 9 times the square root of 5. So so what is this? This is 3. This is 2, right? This is the square root of 4. So 3 times 2 is 6. So we have 6 square roots of 5 plus, what's this right here? The square root of 9 times 9, the square root of 81. That's, of course, just 9. So 6 times 9 is 54. So plus 54 square roots of 5. And then what do we have left? What do we have left? We have 6 of something plus 54 of something. That's going to be equal to 60 of that something. Just like that. Let's just do one more. And we're going to have some abstract quantities here. We're going to deal with some variables. But I really just want to do it to show you that the variables don't change anything. Let's say if we have the square root or the principal root of 48a, and I'm going to add that to the square root of 27a. So once again, let's just factor the 48 part. We'll leave the a aside. So 48 is 2 times 24, which is 2 times 12, 2 times 12, which is 3 times 4. So we can rewrite this first expression here as the square root of 2 times 2 times the square root of 4 times the square root of 3. Now, you might have done it a quicker way. You might have just factored into 3 and 16 and immediately realized that 16 is a perfect square. But I did it, just kind of the brute force way. You'd get the same answer either way. And of course, not just the square root of 3, you also have the square root of a there. So I'll just put the a right over here. I could put it in a separate square root, but both of these aren't perfect squares, so I'll leave both of these under the radical sign. Now, 27 is 3 times 9. 9 is a perfect square root, so we can stop there. So the second term, we can rewrite it as the square root of 9 times the square root of 3a. And in both of these, you can kind of view that I'm skipping an intermediate step. The intermediate step, I could have written that first expression as the square root of 9 times 3a, and then gone to this step. But I think we have enough practice realizing that 9 times 3a, all of that to the 1/2 power, or taking the principal root of all of that, is the same thing as taking the principal root of 9 times the principal root of 3a. So that's the step I skipped in both of these. But hopefully that doesn't confuse you too much. And so this term right here is going to be a 2. This term right here is going to be a 2. So this is going to be 4 times the square root of 3a. And then this over here, this right here, is a 3. So this is going to be plus 3 times the square root of 3a. 4 of something plus 3 of something will be equal to 7 of the something. Anyway, hopefully you found that useful.